So welcome back. Just people are still joining, but let us start the webinar. First of all, thanks for joining us today. Yes, my name is Herbert Ettlinger. I'm the head of product and support engineers here in Vienna. So one of the very old ones, being with Cubro, so since right from the beginning. And I have the pleasure today to talk you through one of our key areas. What we are doing is about network packet brokers, and want to talk about the technology behind it, and also what we have some different packet broker ranges. And the goal for today is to make you aware what these products are, and to choose the right packet broker for your use case, so that you will be able afterwards to see, hey, for this I need that, but for the other thing I need something else. So this is what about. In terms of housekeeping is you have the chat. So we have a Q&A session planned at the end of the webinar. Whenever you have questions, you can wait until the end, or you can also do it during the webinar and put your question there. Also, in terms of the handouts will be available for download in the platform here. And also during the webinar, we have some poll questions that you are welcome to answer. Okay, so far to that. So let's move on. Let me now share my screen to see a little bit more and remove me, so to say. The man, I did it already. Perfect. Good. So as we said, today we talk about network packet brokers. And in fact, what it means is this is our agenda, let's say, for today. Let me just use my laser pointer. Is very briefly, we will talk what is a network packet broker, what is the purpose of it, and then we will talk really about these facts, is how we do classify packet brokers, what is an aggregator, what means next generation, and so on. And of course, at the end, we will do just some summary and some question and answer session. But as we said, feel free, if you have question on the way, you can put in the chat and we will try to answer. My colleagues are here to supervise me and help me. Good. So what is network packet broker? So just that we all talk about and be on the same page, so to say, is a packet broker you can consider as like a switch type device. So what we do is, imagine you have a lot of data. We actually getting this data. This data can come from span ports. They are also coming via tapping devices. And what the packet broker does, it prepares the data. And data is maybe the wrong word, because packet broker prepares the packets. So we're still talking about packets. It prepares the packets so that they connected. It can be analytics tools. It can be a security tool. It can be a capture tool, a troubleshooting tool, call monitoring tool. So it prepares these packets so that these guys here on bottom, that they can make best use of it. Best use of it, of course, also means that they see really what they need to see, but not more than they really need. Because, of course, it's always very price sensitive. The more data you feed, the more performance you need, the higher the price will be. So packet broker is a way just to distribute the traffic in the right manner, so that all of these people here can really make use of the data, not to be overflowed, but also not to miss something. Okay, so we are in the network packet broker, we are optimizing this traffic that is coming to us. Okay, so can considered as some packet distribution system with some intelligence behind. So it's not just to broadcast everything, so to do it selectively. Okay. So very typical scenario. I think most of you who have worked with packet brokers know. So this is very typical. As we said, we're getting traffic from the network. This can be from spam ports, can be coming from tapping, and then comes to packet broker. So what packet broker does is it does aggregation. What means aggregation is, in this example here, you see 4 inputs, let's say, but there's only one output. So that means aggregation. So actually we put together everything from the many pipes only to one pipe. Yeah. So this can be n to 1, so 4 to 1, but of course you can also have more outputs. We can also distribute the traffic to not only one of these IDS systems, like in this picture here, but to more. So we can load balance the traffic and distribute it. Of course, very often we can remove some traffic that is not needed because it's not of any benefit. It will just overload our analytics tool. So we can filter that. Very often also network is high speed, maybe it can be 100 gig, it can be 40 gig, even 400 gig, but our analyzer maybe is only 10 gig bandwidth or 10 gig connectivity. So what we can do is we can also have a speed conversion. Okay, so adapt the interface speed to make use of the IDS manager, even if the network speed here would increase. Okay, tunnel removal, last point, let it just stand for the time being because this will talk anyway later. Okay, so MPP actually is a technology, let's say, to eliminate blind spots. So first feed everything to the MPP and then decide on the MPP what you need and where you need it. Okay, so very easy start, let's say. I think we are all in agreement. Everything is fine. Sorry. Uh, yes, and now comes the very complicated slide. So don't worry, I will try to explain, even complicated for us sometimes. And the only thing, you don't need to look into any detail at this moment, but these are Cubro packet brokers. So first of all, it's a huge range. Okay. Okay. Sometimes, get a little bit frightened of it, but the good news is there's always a solution for a use case. And important now is that we classify the packet brokers. We say there's classical layer 4, then we talk about advanced, and then we talk about next generation. And as we said today, after the webinar, it should be more clear to you what you need at, at what situation. This is actually the purpose. So no need for now to go into details, but just that you see there's a classification of it. And classification here is a little bit bigger picture of the same as we have seen before. Yes, and there's always people say, hey, it's very clear. Of course, next generation is always number one. And classically, this is maybe only, not so good. Yes, this is, you can say it like this, but of course, is also, it depends very much on what you want to do. So it can happen that the classical is a better choice than the next generation. It's depending. And these dependencies, this we will work out now. Okay. Let's start. Of course, we all have to start with the entry level, so to say. And entry level is the classical layer 4 packet broker. And very often is referred as aggregator. I personally don't like the word aggregator because aggregator, how to say, maybe it's not a negative word, but it assumes that it has only aggregation functionality. But of course, the aggregator can do more than aggregation. Okay, but as we said, classical sometimes is aggregator, so don't be confused about that. So first thing we need to clarify, of course, is what means layer 4. Why we Cooper call it layer 4, because usually this kind of family of packet brokers that goes up to layer 4, and this is the OSI layer. And what these packet brokers can do is they can handle packets up to layer 4, so up to transport layer. Okay, transport layer typically in our world is TCP or UDP protocol. Of course, there's others, yeah. So it's never complete, but most popular is TCP or UDP, and they make sure to transport information. Underlying, you have then IP. IP, this is just this how the data are going through a network, and below you have the layer 1 and layer 2. This is usually referred as Ethernet. It gives us the bit rates, these interface speeds, 10 gig, 100 gig, 40 gig, 400, whatever. It also talks about coding. It talks about the media. Is it optical fiber? Is it copper? And so on. Yeah. So what we can do is with the classical one, we usually go up to layer 4. Hmm. Uh, but how can I imagine that? What does that mean to me? What is the benefit? Let us just make one example. Of course, yeah, it's never complete, but just maybe that for better understanding is. And a typical layer 4 use case is DNS filtering. And what means DNS? DNS, domain name system, is actually how you can consider is like a phone book. And what DNS makes, it translates domain names to IP addresses. So when you do Cubro.com, it will resolve that into an IP address. And sometimes people want to see the DNS communication because they need it um, for some security tools or for some performance verification. How fast is an answer of the DNS server, and so on and so on. So if you want to check DNS, there should be a way to take it to, of course, to take the DNS traffic. So how can we do that with a packet broker with layer 4? The beauty is, here's just an example of the well-known Wireshark, let's say, and what you see, here's a standard query. You see somebody is checking for Cubro.net. Yes, here's the answer, Cubro.net, this is the IP address. And how can I capture these packets? Because I only want to see these ones. It's relatively simple. DNS runs via UDP. So this is defined and it uses port number 53. So also the layer 4 port number identifier is fixed, so to say. It's using number 53. So here you also see the answer. So this is the request. This is the answer. You see again port 53. So how we can do that with our classical layer 4 packet broker? Yeah, this is for example is an example of a GUI. What can you do? You just say here UDP 53. And when you run this filter, yeah, it's done. This is all you need to do. And you have your DNS traffic and can send it to the DNS analytics system. Nothing else than that. And this is what is meant by layer 4. Of course, you can also define IP addresses because they are layer 3. You can also filter for MAC addresses or whatever. So all these parameters are possible to be handled in a classical layer 4 packet broker. Yeah, here's some typical filters. Yeah, as we said, we can filter for MAC addresses. We can filter for VLANs. If you can, sometimes traffic is classified or packets are classified with VLAN IDs. Yeah, we can take out the whole VLAN ID. Of course, you can combine these filter criteria. You can say a specific VLAN plus a specific IP address and so on. Yeah, layer 4 port number. This is what we have just seen. This is the one example UDP filtering. So, and now if we're coming back to this complex matrix, the matrix is not so complex anymore because what you see here, these are our product names. And the difference are not the capabilities. The differences between the different models are the ports. The ports it has, so the physical ports. So it's starting actually here with the smallest one, we call it 5.3, that has 48 ports for 10 meg, 100 meg, and gigabit copper, okay, and 4 ports for 10 gig. So this is the entry model. So it has physical copper ports. Still very popular, believe it or not. So this is entry, but still important. But of course, when you look further, what we go up here and here, the slide, it's not 100%. I mean, the slide is correct. Yeah, is correct, but there's actually another column coming here. I'll tell you in a second. But currently, we call it C64. It has 64 ports for 100 gig. So you see, we're coming from 10 meg up to 100 gig, and the next column is the 400 gig column. So there's a 400 gig product launched within the next days. Okay, and here you see the capabilities of it, but important is the port count and the port capability. This makes the difference in the so-called aggregator series or classical layer 4. Basically, they can do aggregation and they can do filtering, they can do load balancing of standard IP version 4 and IP version 6 traffic. This is the mission of it. Okay, the good thing is, these, everything we have said so far, is done in hardware on a dedicated chipset. What does that mean? So it's not running on a software, well, classical software approach with a CPU or something. No, hardware, it means endless performance. So usually these boxes, they can work on 100% wire speed at all the ports at the same time. So they are not losing packets. So this is the development goal. Do everything in hardware, be super fast and very high performance. Okay, so this is the aggregator series. If we go one step further, is what we call it advanced ones. So what are now the improvements, so to say? And the improvements is what we have seen in the recent years. And yeah, at this moment, these advanced ones are our most successful products. Okay, so these are majority. It's not like that we only sell these. Of course, there's a lot of classical layer 4 because sometimes they are fully enough and you don't need the capabilities that I try to explain in a second. But nevertheless, because of complexity in the networks, yeah, there's a strong trend towards the advanced ones. And why we have advanced? And basically, it's about we are talking now about not standard IP version 4, IP version 6 packets. No, very often these packets, they are running in tunnels. So they are somehow encapsulated. And what means tunneling in general? Tunneling is a process to encapsulate, so to take the standard IP version 4, IP version 6, or Ethernet packet, and then you want to transport somewhere else. Not possible in general, but by encapsulation, meaning putting a new header on it, you can route through a network and send it somewhere else where it's needed. So basically, tunneling in general, to be a little bit careful, but in general allows a layer 2 connectivity over layer 3. So send your packet SDR without changing and send it somewhere else. That is usually tunneling. And the key elements of tunneling is it's of course an encapsulation process. So you take your original data and then encapsulate it. Include, of course, you don't want to change your original information. This would be an alternative, but sometimes this is no good. And you can explain it like that your original packet is the payload of a new packet. Okay. And new packet means we add a new header. That means you add a new IP addresses. And these IP addresses then you can use to route through your network. You use new MAC addresses in front, and that is a new header. For example, like GRE, if you've maybe heard about that, but we'll come to that. Of course, there's different tunneling protocols, depends very much on the requirements. We have heard about ER span, GRE, VXLAN, and so on and so on, Cisco Fabric Path, and there are many others, so to say, depending on the requirements of the network and what is really needed. And of course, never forget, once you have done the encapsulation and the packet eventually arrives at your end destination, very often you have to remove the tunnel again because the tunnel is just like a media. It is not of any benefit usually. It's the only benefit to use your infrastructure to transport the original information. Usually, there's always exceptions. And yeah, use case we said just to extend the layer 2 over layer 3 network. So layer 2 information, Ethernet frame, or you ever call it, over layer 3 infrastructure. And very important, what we have seen now with MPP is people talking about remote mirroring. What means that? Remote mirroring, for example, you have a mirroring instance that is somewhere, some device, some server, some instance, whatever. It can be even some services running in cloud. You want to mirror that out and send this traffic somewhere else. So what you have to do is you set up a mirror instance. In the mirror instance, you want to mirror out and send it to your traffic analyzer. So what you do is you, for example, build a tunnel from the mirror instance, from the virtual routing to your traffic analyzer, just to use your data center underlay network. And then you need GRE tunnel. Okay, so this is very popular. We are very often confronted to that. There are some difficulties involved that we will touch in a second. Also, what we very often people talk about, remote span. Remote span, again, you're making a span somewhere remote, not at the site, so to say, but this remote span you need to mirror out. You need to send somewhere else. And then you can use a technology called span or airspan, whatever. Yeah? And this is the same. So making you want to see this information from here, you can mirror it out, but how you get it over here, over there, yes, you need to have a tunnel. So between here and here, a tunnel is existing. And then what does it mean, tunnel? The information that you had originally is hidden in this tunnel. This we will see in a second. For example, here's just an example of another technology, VXLAN, for example. And if you take a look on this Wireshark picture, what you see here at the bottom, you see again, hey, port 53, this is what we have talked. This is DNS, cool. Yeah, but in front, there's Ethernet, there's IP, there's UDP, there's VXLAN. So all these header is called VXLAN tunnel. Hmm. Yeah, okay. What is the problem now? The problem is when you have classical layer 4 packet broker, yeah, it can, of course, it can do filtering UDP, but it will only go to this point here. It sees UDP, but this is never port 53 because port 53 is here. So much further down in the packet. And the classical layer 4 packet broker cannot do the filtering here on this inner part because it can only filter on the outer part. So therefore, no, is no good. Of course, the classical layer 4 can aggregate this. Everything is fine, but it cannot do the filtering. Okay, because the port 53 is hidden by these VXLAN tunnel parameters. Okay, and usually what we are interested when we talk about security, when we talk about capture, when we talk any analytics, we are usually interested in the information, in the payload. So in that, what is coming here, these parameter, tunnel parameters, yeah, is good that they are there, of course, but tunnel is just like a media to help us to get this information over to another place, but in fact doesn't have any value usually. Okay, so as we said, hidden. Information of interest is hidden because of these additional parameters we need to use. So just to get a little bit more complicated, very often today we see, hey, there's not only one tunnel on the packet, there's more. In this example, you have span and you have your VXLAN. Okay, very normal scenario. So if people say, yeah, but I'm only interested in this here, you see here protocol diameter. Mobile people will know that. And I can easily filter out by port number. Yeah, but how you want to filter? There is one header here, another header here. So classical layer 4 will not help you in this case. It can still do aggregation, we said, perfectly okay, but it cannot filter for that. And here's just an example also for GRE. For encapsulation, to make you aware, of course, any encapsulation will make your packet bigger because you have additional parameters, additional IP addresses, and so on and so on. Yeah. And usually what we do is then here is the inner. We always call it inner IP. Is maybe a little bit wrong because it's not only IP, it's also inner MAC and inner layer 4. So what these advanced boxes can do is they can remove the GRE header, but at the same time, they can also do the filtering of the inner parameters. So if the inner port is 53, because you're looking for DNS, so they can filter for that. So they can ignore this tunnel and still find the right packet for us. That is actually what advanced means. Okay, so this is just a picture of a GUI, and this is how it would look like. And you see here, we have this filter mode. It can say tunnel outer layer. Yes, it filters for the outer layer here, or inner layer, then filters for here. So yeah, that's very, very popular, so to say, often and very much needed. Also, another question, because we said once we have tunnel sent to another location, very often maybe tunnel should be removed because we don't want to give it to analyzer because it doesn't have any value maybe in that scenario. Very often, and this in general is monitoring tools, they can also remove headers and tunnels. And these people are clever people, of course. I mean, they also can remove. But I'm always saying like this is yes, they can do, but what cost it says. They can say, hey, but this is included. But still, even if something is included, it has a cost because usually it costs performance because this is maybe running on a CPU or by any means, maybe, you know, is a kind of cost in terms of because I have maybe less CPU power than available for other tasks. Okay, so this is one thing. And another thing is this point here, which maybe not worked out so good in this on my slide here, is that usually we can strip tunnels completely transparently without, and that's the key point, manual tunnel configuration. Show you a picture of that. So this is our tunnel strip menu, and you just click here VXLAN. What it means is the box inside has a kind of protocol decoder. Let's call it like this. Basic protocol decoder. It knows the packet has VXLAN on it, and automatically can remove the VXLAN parameters.
Yeah, sorry, Hebert, there
Yes.
is some issue with the screen right now. We can't see the screen at the
Yeah.
moment.
Just a moment. Let me try again. There was some connection problem, it said. Bu- 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 bu. Okay. I try to come back, but you still hear me?
Yes, we can hear
Okay,
you.
this is at least something. Yeah. So I try to share my screen, but the platform doesn't allow me.
Hmm.
Just a moment. Just a moment.
Yeah, I think there is some technical issue because
Yeah, always.
even,
There's always
yeah,
technical
let
issues because
me,
of tunnels. I tell you, so
yes.
complicated.
Should I try to bring the presentation
Please,
on? Yeah,
please
okay.
try. Sorry, guys. Sorry, sorry, sorry. Ah, I see
So,
something. You need to move to page 18, Damana.
sure.
It's always me. Why it's me?
No, I think it's just the platform. Sorry, everyone, for
Yes,
this.
okay. Here we
Okay,
are. Here
there
we
we
are.
are.
Here we are. Here we are. Yes. So sorry, I'm not sure. But anyway, the important issue is so advanced packet broker usually has this decoder inside, so it knows when the packet has VXLAN. And when there is VXLAN and VXLAN is uh, is clicked to be removed, it will remove without any configuration. Because of course I know there's other products. They claim say, yeah, we can remove VXLAN, no problem. Yes, and they can. It's not a lie. It's not. They can also remove GRE, everything, super. But every tunnel they want to remove, they need to configure. Yeah, but it configure sounds easy. I will just configure. But what you need to configure? Usually it means you configure the IP addresses of the tunnel, so source and destination. You configure the MAC addresses of the tunnel and maybe some in terms of VXLAN, maybe the VXLAN ID. So my question always is, Do you know these parameters? If you ask the monitoring people, hmm, I have to ask network people. Hmm. So first problem, sometimes issue, and the next issue is, but what happens if they're going, if somebody in the network decides to change? Yeah, then you do it again. And what we have seen and learned is, look, if you have only two tunnels, then you can manually configure it. There's no doubt. But if you have more, and usually there are more, and you have to configure manually. Yes, you do it once, you hit the box. If you do it again, you kill it. This is the experience. It's completely different from the advanced mechanism. You just click and say, remove it from me, and do not configure. So this is really a huge difference. So as I said, at the beginning, it sounds maybe, yeah, it's not so much of an issue, but later on it will be, believe me. So advanced doesn't need that. Okay, let's, Tamara, how we can move on? I can do. Cool. I can do on my own. Hey. Yeah, just to make it a little bit even more worse. Let's see. These are real examples and people using here two tunnels on top, another two tunnels, and there's examples. We have three tunnels because it's coming from a cloud coming to a fabric leaf scenario, and then is mirrored out on top of the rack, whatever. So yes, these tunnels build up the more complications you have. Okay, so the good news is with the advanced one is, hey, see this? We still do the filtering in the inner part and the removal in hardware. Full performance. Wow, great. So this is still, we're talking about hardware. Before I said to you, it's a kind of protocol decoder. Of course, it's limited protocol decoder, but it's optimized for the packet load. Okay, therefore we can have full performance. Okay, yo, and final point of the advanced product is, look, when you have this scenario on the mirror source side, you have two mirror instances. That means you have two IP addresses that they need to send traffic, but where to send it? Yeah, they can send it to one IP address, which can be packet broker. So that means packet broker needs to actively terminate traffic. Why this is important? So if there is no IP address, um, what will happen? That the packets will never arrive to the packet broker. So it needs to be active, of course. Otherwise, the layer three network in the middle, will not know, where the destination is sitting. Okay, so this is advanced. And again, when you're coming back to this slide with all the products, mm, it's the same as with the classical one. Yes, we have different products. They can do it. And what is the difference is the interface speed. So there are products for 400 gig already. We have the 32, 200, 400 gig, of course. Of course, there's also others. So basically, what we have on these products is we have dedicated chipsets with very high performance or highest performance available. Of course, we have all the features from layer 4, plus we add some extra functionality for tunnel traffic. So anyway, if you come to the situation, you are thinking about tunnels and there is tunnel traffic and maybe some complicated tunnels, yes, then it's always the advanced. If you maybe just have, yeah, it's more standard IP version 4, IP version 6, then aggregator classical is maybe fully enough. Also, classical has some tunnel features, but never comparable to this one, of course. Yeah. Also, very often, sometimes people combine this. You can use an aggregator, of course, as an aggregator. Aggregate the traffic, terminate the 400 gig links on the aggregator, and then send it to the advanced one. There's also a possibility. So there's different scenarios, but important is that classical is rather this one, advanced one is rather this one. Okay, good. So, and finally, what is the next step? Is next generation, we call it. And next generation, but then uh, We no have no animation now. No good. Let me just, yeah. Anyway, I tried it without animation. Or Tamana, you can stop it again. I think I can share again.
Yeah. Okay.
Yeah,
All right. Yeah.
please. Yes, it should. Yes, it's coming. It's still the old slide. Okay, you see it. You should see it.
Yes, we
Yeah,
can see the slides now.
yeah, perfect, huh? It's recovered. Good. Let me use the laser pointer again. So this was it. What I wanted to explain you. So advanced is what we see here. This is the advanced backup broker. So it does all the aggregation, filtering, load balancing, and tunnel handling. And when we then say about next generation, what we do is the following. So we add some CPUs on top. These CPUs are on the same unit, so to say, and these CPUs, they give us some more features. We will explore in a second. Of course, from this part here, that's hardware, as we said, this is the chipset. There is some connections to the CPU. And the one thing you see immediately is, in this case, we have 2 times 100 gig from the switch, from the chipset, from the hardware, so to say, to the CPU. So the first thing is, be aware, it's not endless performance. Of course, the CPU always has anyway a limit. Yeah, so this is clear to, I think, to all of us. But the first limit, which is very evident, is the connection. So it's 200 gig I can send here, not more than 200 gig, because there's only two of these available. Okay, so first time in the packet broker concept, what you see a kind of limitation, because the others, they are working with highest performance. But of course, now CPU can do some things in addition, and that we need to explore. Okay, so that's called next gen. So if we combine these two, what it can do is deduplication. Deduplication means, and really consider this as packets. You have the packet that looks like A, but you get this 4 times. Okay, but you only need it once. And deduplication means it will remove unnecessary copies. This is what it is needed. Of course, because filtering can help you for duplicates, but filtering always needs a criteria. So if packets are an identical copy of each other, there's no criteria. You cannot filter them out. Deduplication can do it, because deduplication, what it will do is it will look into the packet. Okay, it will really check the packet, not only the header, but also including the payload if we want that. And also another point is, sometimes duplicates, they are no duplicates. What does that mean? Very often it happens that you get the same packet, and I mean payload, but it's coming from two different entities. That means maybe the IP addresses are different, the content is the same, or MAC addresses are different, or whatever. So then what can we do that? And there's some parameter we can use. We call it ignore. So if somebody says, yo, but IP should not be compared, then you check the IP box. Then the box checks everything on the packet, but not the IP, and still can find duplicates. Okay, so it's rather something, yes. And then you see, this is clever things. Yes, this is CPU based. So nice things can be done. But of course, always, I mean, has a price tag, of course, but also has some performance limitations. So it goes not up to terabit per CPU. Okay. Also, another issue what we have seen is what the box can do is just some use cases now, yeah, not all, is fragmentation. And what is fragmentation? Assume you have some remote mirroring, and you get from the remote mirroring, you get very big packets. As an example, 10,000 bytes. whatever. It can be also 2000 bytes. So, and this you want to transport over the network, but maybe it's not your network. You cannot guarantee the 2000 byte. We don't know. What can you do? You can use fragmentation. Fragmentation is the process to make out of the big chunk, let's say smaller pieces, like we have it here. And of course, the product, the next generation one, it supports fragmentation. You can put in what is the maximum um, packet size the network can do. So we'll fragment it. Okay, particularly in situations maybe that you cannot control because the network is somebody else or it's only leased or whatever. Okay, this is some possibility of a CPU. Also, this is the opposite of fragmentation is called reassembly. Very often we have seen analyzer products that cannot handle fragments. So they see the traffic for them is incomplete. So they cannot do any analyze. Very often we have seen this, for example, when you talk about voice over IP, we have the SIP invite message. SIP invite message that can be very, very long. People, this is like, cookbook. Everything is written in a SIP invite, but then the packet becomes very big. So then fragmentation could happen also on network side. So it's fragmented, but the analyzer getting all these fragments mm, cannot cope with it. So what reassembly means is that the packet broker assembles again the big message. Okay, this is also one possibility. So actually, what we actually do in the next generation is it's more, so it's more intelligence in terms of payload. So we can take a look in the payload. For example, we also can do regex filter. So filtering up to now, when you remember, uh, was about headers. We can filter for IP addresses, MAC addresses, VLANs, TCP, UDP port numbers. But the next generation ones, they have the possibility to go further to look into the payload, look for some strings, for some regular expressions. This is the purpose of it. But of course, always, as we said, has a cost also for performance, not only money. Good. So just to remember, three different ranges. And as we said, sometimes these products are referred as aggregator like the layer 4. Yes, this is the basic layer 2 to layer 4. Filtering applications is perfectly okay. Sometimes these products are used also together with these ones or these ones and these ones because they can be used as pre-aggregator. And sometimes it's a very economic way to terminate links. Okay, to terminate and then feed together everything to a next generation or advanced. Okay, so advanced, remember, overlay, tunnels. We have tunnels. Yeah, then you're more on this side. If you want then to make something very special with the payload, yes, then we are here. Okay, so this is the how we classify it. So, and also remember, very soon, at the moment, there's no 400 gig aggregator. In fact, there is already. In the next days, will become online, so a so-called C400. Okay, and yes, so our goal as Cubro is always to address these technical needs, different technical needs, but also price need, to cope with all of that. Good. Uh, question and answers. So maybe there have been some questions. Look, let me stop that, and I will go back to the chat. Ah, so if there's any questions, please put it here. Or my colleagues, they have already answered everything. Lucas, you have answered all the questions yet, or no? They okay. No. So if you have no question, it means I explained everything very well. Good, no questions up to now. Good guys. Perfect. So as I said, you still have time. You can put it in the chat. Good. Thank you guys. Also thank you for staying with me and the difficulties. How we can filter. There's one question. How we can we filter in diameter? Now look, we can what the packet broker can do uh, is we can filter for port number and diameter. So Lucas will correct me anyway, or somebody else. 38, is it 3863 or 3868 port? I mean, I can go back to my presentation. I can check, guys. I have the answer. Sorry, I have to look to the other screen. Diameter. We had this slide with the diameter. Uh, Diameter is port 3868. Yes, perfect. Thanks. Yeah, you answered the question. I did not look to the screen. Perfect. Which industry aside from telecommunications are using Cubro? Look, good question. Super. Yes, of course, it's mobile and whatever, but now it's a very good mixture. Also, we have a lot of, look, we call it enterprise. Enterprise is maybe not the right, but enterprise is a lot of utilities, gas, oil, water, electricity. Then we have also a big of finance institutes. We have a lot of banks using our products for time stamping, well, security. We have a lot of OT applications, so more security applications. So it's a quite wide range of customers. Yeah. So it's not only mobile or telecom, let's say. So it's a lot of also others. Can you show some example of packet sampling? Not in the webinar, to be honest. So because then we would need to set up a test and right. Now it's possible to do that in Cubro product. Yeah, of course you can. Sorry, I did not understand before. Look, when you go with regex filtering, yes, you can of course do. Yes, regex filter will be the answer because regex allows you to look into the packet. Of course, with a UDP or a TCP filter, it cannot be done. This is only gives you the uh, all the diameter traffic, but not a specific one. Right. Okay. So Ramon, thanks. You answer all my question. Cool. Yeah, diameter is on SCTP, no problem if it's SCTP or not. As look, remember before I told you is I mentioned on my slides TCP and UDP as just some more prominent, but it can also be SCTP, of course. For regex, it doesn't matter. Okay, so you need to have a more complicated. Good, guys. No more. Cool. Good. Thank you all once again. Thank you. And also please join us next time. Coming soon. Good guys. Then see you. Thank you.